What we have here is a very typical exam question, Algebra 1 and 2. This video is the second part of a four-part series where we examine the steps on how to graph this. So this video, I'm going to look at the second one in detail. What I have here are standardized steps on how to find or graph any of those functions we're given. Step number 1, we're looking for holes in the denominator where the function is not defined. So for example, this one and this one here, when we set the denominator equal to 0, x is going to be at a minus and a plus 1. And that's where the function breaks off because the function is not defined for this case. And for this one over here, x equal to 1, the function is not defined. The reason we want to find the holes is because then we can examine the vertical asymptotes of the function. What happens when the function close to the hole where the function is not defined? Typically, function, of course, blows up on one end and goes positive infinity and negative infinity on the other side. And that's why the function is not defined. After finding the vertical asymptotes, we're going to move on to finding horizontal asymptotes. That's when the x is either really large or really small. What happens to the function? What's the behavior of the function? And from there, the very last step is we're going to look for special values, and that's when x function cross x-axis or y-axis and or y-axis. So let's go through this series of 4 videos, and we're going to follow exactly the 4 steps, and let's have some fun with this. Alright, so let's go through each one of the steps. By finding holes first, we'll take the function and we'll take a look at the denominator where it's undefined. When the denominator equal to 0, we solve for that for that special value, x equal to 1 and minus 1. That's when the function is undefined. As you can see, function breaks up at plus and minus 1. That will eliminate quite a bit graphs for us. Second one we do is right around the holes, so that's 1 and minus 1. We're going to take a value on either side of 1 and either side of minus 1, and we see what happens to the function. That gives us the what we call the vertical asymptotes. And the third step after vertical asymptotes, what we want to do is to take a really large number and see what happens to the function. Say 1,000 or minus 1,000, and we see the function is close to 2, above 2. That gives us some clue that when x is really large, the function is going to stop at 2, which this one eliminates this one, and this one. So is this one, and all those are eliminated. This one is actually not eliminated, but so far this one is eliminated as well. So far we eliminated quite a few of them. Alright, and the last step is that special value. When x equal to 0, and we can see that 0 is 0, produce g of 0. So function is at 0. Function equal to 0 when x equal to 0. So therefore 0, 0 must be a point, which means you eliminated this point, this graph, because 0, 0 is not on the graph. The only one that's on the graph, which satisfies all 4 requirements, is graph number 4. So let's do a quick summary. Alright, quick summary. We are looking at function, this one, g of x, and from step number 1 and 2, we took a look at the vertical, where the vertical asymptote behavior is, where the holes are. And then from number 3, we took a look at the horizontal asymptotes. That gives us the behavior analysis close to 2. And the last step, 0, 0, is a special point on the graph. So step number 4 gives us this one. And then in the end, the function g of x corresponds to graph number 4 over here. Alright, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video or hit the like button. Together we can make math easy again. Have a confident day.